Hi everybody, welcome to watch our video course on Ruff IoT Application Development again. In our previous chapter, we learned hardware control for Ruff application development. The entire chapter revolves around the things in IoT. In that chapter, we've learned how to add a device, how to operate a device. However, that doesn't complete the application development in IoT. But the most important thing in the entire IoT architecture is to realize network connection. Only upon the realization of network connection can we remotely control a device, like sending a command to make a device turn on a light, or sending a command to make a device acquire surrounding ambient temperature, and then transmit that temperature back to us. Well, from this chapter, I'll lead you to learn an operation of networking in IoT. This whole chapter is divided into 4 parts. In the first 3 parts, I'll introduce you to some common communication protocols, TCP, HTTP, and MQTT, as well as their usages. In the last part, I'll guide you to finish a simple case, to turn on a light remotely. Well, let's first look at the TCP protocol. TCP protocol is a communication protocol at the transmission layer. In fact, as we know, the transmission layer is a very low bottom layer. Speaking of TCP, we may think of socket. Socket is actually to realize a layer of encapsulation and abstraction of TCP protocol, and exposes an API of socket standard. Well, in the TCP protocol, we often use the IP address plus a port number, such an information pair to describe a communication party. Under a scenario of TCP protocol, there are often 2 roles. One is server, as the service provider, and the other is client, as the service user. When the service enables monitoring, the client may attempt to connect, and one server may be connected to several clients and communicate with each client. Our Ruff provides a net module. In fact, this net module provides some encapsulation to the API of sockets, and then realizes the TCP communication protocol. And in fact, Node.js also provides a net module. The net module provided by Ruff is actually compatible with the net module of Node. For example, both may be executed when Node or Ruff is operating. Well, as to how to use Ruff, a reference address of an API is provided here. Let's find its documentation in Node.js. We may first go to a homepage of Node.js, and then click this doc. Then click this API. And here, find this net module from all the modules. This web page covers the usages of the net module, and the usages all APIs. Well, in programming, we often define a net, and then burnet. To define this module in such a way, in the net module, there are 2 highly important classes. One is net.server, and the other is net.socket. And server is actually, as we mentioned just now, such a service provider. When it starts monitoring, the client launches a connection to the server. Upon connection, the server acquires the successfully connected socket, and the newly created socket will conduct a peer-to-peer communication with the client socket. Now, let me guide you to look at a real case and practical use. First, look at the server. The code first. First, ver, a net, and use this net to create a server. Then it starts an event on connection. After that, it monitors port 7777. In the callback function of the connection event, it will actually, for the callback function, it has been successfully connected. Upon successful connection, it will enter this callback function. Throughout the callback function, it will launch the onData event one by one. That's to say, when the client transmits some information, we'll enter the callback function of data. And when the client turns off the connection, it will enter the callback function of close. And in the callback function of data, the transmitted message will be printed, and then the server actually sends a message to the client, saying that I'm the server. After it starts monitoring, after this action is triggered off, it will make a listening event on, and it prints. The server is monitoring port 7777. Next, let's talk about the code of client. As mentioned before, the client needs to actively connect the server. For this reason, in the code of client, there should be an ID tag for the client. As mentioned earlier in TCP, an ID tag often consists of an IP address plus a port number. In the code here, as we see, first, a post and a port actually defines the IP address and the port number. Launch a new socket, and then start connection. Upon connection, it entered this callback function, and the client sends a message, "I'm the client," to the server. After the client receives the message, it enters the callback function of data. First, it prints the message, and then actively closes itself, like closing this connection. When the time of server close arrives, the client enters close, such a callback function. It prints such a string, close. Have a try. Before that, let me explain it. Whether in Node or Ruff, such a code can be executed, since the net module is actually compatible with either Node or Ruff. Here, we use Ruff to execute it. As I see, the server actually has started monitoring. Then, we use Ruff client to launch this connection. As we see, in terminal of server, it prints "I'm client," and prints "I'm the server" in the terminal of client. Like we mentioned before, our server may be connected to several clients. Let's try it again. We can see the same effect. Okay, that brings us to the end of this lesson. Alright, so that's all for this lesson. So please look forward to our upcoming classes on Ruff. Thank you very much.
Ruff, make IoT easier.